In this tutorial, we're going to have a look at some of the things that may be confusing when you first start working with inheritance. And we're also going to look at something called polymorphism, which is a common interview question that employers love to ask. So it's going to be really important that you understand the difference between inheritance and polymorphism when we get to it. Now, I've already stubbed in some code in here, and it's just to save time. But let's go ahead and look at this. At line 2, you can see that I've created class dog, and it extends object explicitly. Now, first of all, realize that whether you like it or not, all classes are going to inherit from a class called object. So if you go all the way up the hierarchy, you're going to see that object is at the top of this inheritance hierarchy. In other words, if you look at it this way, class dog extends object, this code right here is the exact same as the code right here when I remove those two words. So whether I like it or not, we're going to inherit from object. So let me undo that. Now on the inside of dog, you can see that we have two attributes. I didn't include rabbit, but I have two attributes, string name and int weight. At line 6, I have a constructor, and you can see that it takes in a name and it also takes in a weight right here. And I also wanted to put this line right here, 7, in there just so you could remember that when we refer to this, I'm referring to the class, something with regard to the class that I'm inside. So this.name refers to our attribute up here, and I'm assigning this.name to be whatever the parameter name value was coming in right here. I did the same thing in line 8. This.weight gets W, so I'm referring to this.weight right here, gets assigned whatever value W had. Now a little bit further down, we have a method inside bark. It doesn't do anything magic, it's just a simple print statement. But void bark says system.out.println, and it prints out grr. So then looking a little bit further down in the code, you can see that I've created a poodle class as well, and it inherits from dog, which inherits from object. I also included a constructor right here, and notice on the inside of this constructor, I did something that's a little bit strange. I called super. Now anytime you see the keyword super, it's referring to the parent class. So right now, because I'm inside of poodle, if I refer to super, I'm actually referring to something up here in the dog class. Now when you call super by itself, it's actually calling this constructor right here. So notice that these things match up, right? I say super and I pass it name and W. Those go in here into the parent's constructor, and it initializes it the same way that the parent initializes. So believe it or not, this code right here, this call to super, is going to be there whether you like it or not. It's more invisible code that's there, and you're going to see that here in just a second. Okay. Also notice here in Poodle that we've redefined bark. We overrode the bark because we weren't happy with the one that we inherited. So in this case, if I tell a poodle to bark, it's going to, instead of printing out grr, it's going to print out yip. Okay, now to really show off this problem of calling these constructors, to call this dog constructor up here, notice that I have class wolfhound extends dog, so we're inheriting from dog just like poodle did. And I tried to create a constructor here, but it's complaining about it. The error that we're getting, it says implicit superconstructor dog, and notice that dog has no arguments to it right there, and that constructor right here is undefined. So there's two different things that are going on. By default, like I said, there's some invisible code that's here. This code is there whether you like it or not. And it's complaining, it's saying there's no constructor that takes 0 parameters right now. So we can solve this one of two different ways. I can either pass it the expected parameters here, name and W, and you can see that solves the problem because it calls this constructor that's there. Or what I could do is, I'll take this back out, I could come up here and I could add another constructor that's empty. I could say dog and just have it empty and really not do anything on the inside. I could maybe say name gets Bob or whatever it is that you want to put here and give some default values. Or, check this out, I could also say this, and this calls this constructor right here, passing it Bob, and let's say its weight is 5 or something like that. So we have a couple of different ways that we can call constructors. Notice that right now I'm inside of dog. So if I say this just by itself, I'm actually referring to one of the constructors. And yes, I can have multiple constructors inside of this class. Okay, so let's just call the constructor that we want. I'll say super, passing it name and W. And notice that the wolfhound doesn't override the bark method that we've inherited right here. All right, now that's the layout of this class diagram, but we actually need to start creating instances or objects of the poodle and wolfhound classes. So let me show you the most simple form of polymorphism. And polymorphism is when you have a parent object refer to an instance of a child. Now, what does that really mean? Let me show you. If I were to say dog D gets a new dog, this would totally be allowed, and I could pass it the right stuff here, but I'm not going to. But also what I can do is I could say dog D gets a new poodle, and let's pass the name Fluffy, and the weight of, I don't know, 1 pound, something like that. Now this is a partial example of polymorphism, but why does it work? It's a little bit strange. Notice that the data type on the left side of the equal sign is a dog. The data type on the right side of the equal sign is a poodle, but because of inheritance, it's also a dog. So therefore we have a dog on the right side of the equal sign and a dog on the left-hand side, and therefore we can assign a poodle into a dog. Now conversely, we couldn't say something like this. I couldn't say poodle P gets a new dog, because it doesn't work that way. A dog is not necessarily a poodle, but a poodle is always a dog. Where it gets a little bit interesting is when I tell D to bark. When I do this, it's going to bark like a poodle because currently D is a poodle, right? So it's going to run this method right here that we overrode. Now a little bit later on, what I could do is I could say D gets a new wolfhound, passing it, I don't know, the dog's name is Macho or something like that, that weighs 100 pounds. And now if I say D.bark, now when I say D.bark, it's actually going to bark like a wolfhound. So when I run this code, you're going to see that the first time it barks, it's going to bark like a poodle because at line 36, during runtime, D is a poodle. And then a little bit later on in the code, here in line 37, we change D's data type to now be a wolfhound. And then when we tell it to bark, it's actually going to bark like a wolfhound. So that's where the name polymorphism comes from. It's changing data types on the fly, and it's morphing from one thing into another one. Poly meaning multiple, morphism meaning that it's morphing, that it's changing form. Now where it gets a little bit more interesting, here, in fact, let's just comment this out. Where it gets a little bit more interesting is when we start to create large sets of different kinds of dogs. And watch what I can do. I can come down here and I can create an array of dogs called kennel. Gets a new dog, 10. Now realize when we do this, we don't actually have dogs in the kennel yet. We just have slots that could hold dogs a little bit later on. Now I want to loop through here and I want to put different kinds of dogs in the slots. I want to put a poodle in one slot and a wolfhound in the other slot. So how am I going to do that? Well, I'll say for int I get 0 so long as I is less than 10, or well, let's say kennel.length. Okay, I++. Then what are we going to do? I could say if I mod 2, and again remember that's the remainder after division, is equal to a 0, in other words it's an even number, then kennel of I gets a new poodle, and we'll give it a name of Fluff plus whatever I is, so Fluff 0, Fluff 2, etc., and then its weight will be I. Okay, otherwise, what are we going to do? We will put in a new wolfhound. Gets a new wolfhound. And here we'll call the dog, I don't know, Wolfie plus I, so that they have unique names. And then let's say it's I times 10. Okay, so at this point we now have an array of dogs, but inside of this kennel you have a poodle, and then you have a wolfhound, and then you have a poodle, and then you have a wolfhound. So we have a whole bunch of different kinds of things inside the kennel. They're all dogs, but they're actually subclasses of these dogs. Now, where does the polymorphism come in? Well, here's the interesting part. When I say for int I get 0, so long as I is less than kennel.length, I++, when I tell the dogs to bark, They're actually going to bark like the kind of dog that they are. But watch this. I could say, in fact, we'll make it more explicit. I'll say dog temp. And then I'll come down here and say that temp gets kennel of I. So what we're doing is we're taking a dog out of the kennel and we're putting it into temp. And then we'll tell temp to bark. But it's going to start to complain here, because it's going to say, hey, well, how do you know what's coming out of the kennel is actually a dog? What I could do to make it explicit is to put a typecasting right here of dog, saying whatever you pull out of this kennel, we're going to cast it to a dog and then put it into temp. Now the interesting part is, because I put a poodle in first and then a wolfhound, when I tell all of the dogs to bark, this code right here is going to go through and tell all the dogs in the kennel to bark. I'm going to get some interesting output. So here, if I scroll through it, come down here, you can see that the first dog says yip, the second dog says grr, the third dog says yip. And so again, polymorphism, this temp variable right here is changing from a poodle to a wolfhound, back to a poodle, back to a wolfhound. So then the question is, why does this work? Well, I'm guaranteed a couple of different things. If I come up here and I look at dog, you can see that we've defined a method called bark. Now we have one of two different options here. Poodle could have either overridden bark like it did, or it could have not overridden it and inherited this bark method. So no matter what, when I come down here and I pull a dog out of the kennel, I'm guaranteed that it has that bark method in it. That's why polymorphism works, is because those methods are guaranteed because of inheritance. So if somebody asks you, what is polymorphism and what's the difference between inheritance, you know that inheritance is when you absorb all of these attributes and methods from another class, but polymorphism is when you have a parent pointer pointing to a child object, and then you call the methods on it, and it's going to behave like whatever that object is. And remember, the reason that polymorphism works is because of inheritance. You can't have polymorphism without having inheritance. So that's it. Hopefully you understand a little bit more about the practical implementation of inheritance, and you also understand a little bit more about polymorphism.